Today we are going to be using right triangle trigonometry in order to solve problems. And before we look at some examples, we have two important terms to discuss here: angle of elevation and angle of depression. Now, angle of elevation, if you think about that word elevation, you think about going up, right? So angle of elevation is the angle you look up from the horizontal to see something. Elevation, you're thinking going up. So you see this person, and instead of looking straight ahead, he is looking up at this plane. Here's his line of sight. So his angle of elevation is this angle. It's how much he had to turn his head upwards to now look at the plane. Angle of depression, if you think depression in somebody is down, right? They're sad. So think of angle of depression as how much you have to look down from, again, the horizontal to see something. That's like if you were at the top of this tower. It's always instead of looking straight ahead, because you think in life you're normally looking out in front of you, right? So angle of depression is instead of looking straight ahead, I'm looking down at the ground at something. This would be your angle of depression. It's how much you turn your head downward to see something. So think of it as always from straight ahead. Instead of looking straight ahead, you might be an angle of elevation because you're looking up. Or instead of looking straight ahead, you might be looking down to see something. And when you look down, that would be an angle of depression. So it's always instead of straight ahead of you. It's always off the horizontal. Okay? Example here, the angle of elevation. Remember, that would be how much you're looking up from a sailboat to the top of a 121-foot lighthouse on the shore measures 16 degrees. To the nearest foot, how far is a sailboat from the shore? Alright, let's decipher what we have, label what we know. The angle of elevation from a sailboat, okay, the angle of elevation would be from the sailboat how much you're looking up. So this is that angle of elevation I'm looking for. To the top of a 121-foot lighthouse. Oh, okay, the lighthouse itself is 121 feet tall. Oh, this is the angle of elevation. The angle of elevation measures 16 degrees. How much I'm looking up from the sailboat is 16 degrees. Instead of straight ahead, I'm elevating that much. To the nearest foot, how far is the sailboat from the shore? The sailboat to the shore would be this distance here. I'll mark that as X. In these real-life problems, generally you're not solving the whole triangle. You're just looking for one unknown. Here I need this distance. We do have a right triangle. I would assume the lighthouse would be at a right angle with the ground. Let's think about what trig function we need here. Here's my reference angle. For that angle, the side I know is opposite from it. The side I need is actually the adjacent leg, right? This is the hypotenuse, so this would be the adjacent leg. And which trig function relates opposite and adjacent? That is tangent. Now you're always doing the sine or the cosine and tangent of the angle. Here I'm doing the tangent of an angle that measures 16 degrees. And tangent equals opposite over adjacent, 121 over x. Remember, when that variable is on bottom of that fraction, I can't solve it until it's off of the bottom. So first multiply by x so that x becomes on the top here. Now it's multiplied by tangent of 16, divide by tangent of 16 to get rid of that. Divide this by tangent of 16, and we'll be good to go here. In the calculator, 121 divided by the tangent of that 16-degree angle. The distance the sailboat is from the shore is 421.98, and this is in feet. I guess they did say nearest foot, so I could say 422 feet. Okay. So again, labeling what you know, solve for what you don't using trig. Another example, looks like I'm going to need to draw a picture here. From the top of a tower, the angle of depression to your friend on the ground is 72 degrees. The top of the tower is 80 feet above the ground. How far is your friend from the foot of the tower? Okay. I'll draw a really detailed picture of my tower. There it is. From the top of a tower. So you must be like up here. The angle of depression. Okay, this is where you need to be careful. Anytime you're talking angle of elevation or angle of depression, it's always instead of looking straight ahead. Because even if you're at the top of that tower, you're probably going to be looking straight ahead. The angle of depression is how much you're turning your head downward. Instead of looking straight ahead, how much you look down. And that angle of depression is 72 degrees. So you're looking down quite a bit here. This is 72 degrees. We also know the top of the tower is 80 feet above the ground. So the tower is basically 80 feet high. Oh, and you're looking at the angle of depression to your friend on the ground. So your friend is down here. Question is, how far is your friend from the foot of the tower? Well, your friend is this distance, whatever it is, from the foot of the tower. We're assuming we have a right angle with the foot of the tower there. Now, there are a few things you can do to actually get an angle in this triangle, because if you really think about it, the triangle doesn't have any known angles. That 72 degrees is kind of outside of the triangle, right? It's the angle of depression. But here's something, you know. If you were looking straight ahead, and we assume that that would be parallel to the ground. So now you have alternate interior angles if you want. So 72 degrees would also be the angle of elevation that your friend would look up to you. So it's kind of cool. Angle of depression, angle of elevation are always the same thing. Your friend would elevate his head 72 degrees to see you. You are lowering your head 72 degrees to see him. The other way to think of this is a right angle in total. So you can do 90 minus 72 and realize that this angle is 18 degrees. So that these two add to 90. Honestly, it's up to you. You have a choice whether you're going to use the angle of depression and make that the same as the angle of elevation on the ground because of alternate interior angles off of parallel lines. Or, knowing that we have a right angle here, those two add to 90 and you can find that adjacent angle. Either way, you need an angle in the triangle. Okay. So it's up to you which one's the reference angle. I'm just going to highlight, how about I highlight the 18 degrees? That'll be my reference angle. It's up to you again. If that's my reference angle, what would I label this side I'm looking for and the side I have? Remember, opposite, adjacent, or hypotenuse. From 18 degrees, X is located opposite from it. This 80-foot top of the tower, that is the adjacent leg. It's not the hypotenuse. So this is adjacent. What trig function relates opposite adjacent? Tangent. And we know we do the trig function of the angle. So I'm doing tangent of my reference angle, which was 18 degrees. And then equals opposite over adjacent, x over 80. And in this case, you have the variable on top. X is being divided by 80. To solve for x, just multiply by 80 so it cancels. And I'm going to do 80 times the tangent of 18 degrees. And it looks like x, which is the distance your friend is from the bottom of the tower, is 25.99. And this was feet? Yeah, because the tower is 80 feet. He's about 26 feet from the bottom of that tower. Does that seem like a reasonable number? 18 degrees was very small compared to 72 degrees. 72 degrees was across from an 80-foot side. 18 degrees across from a 26-foot side? Yeah, that seems reasonable. So today, using right triangle trig to set up real-life problems using angle of elevation and angle of depression. Remember that both of those are, instead of looking straight ahead, it's how much you either elevate or look down.